Hey guys, Mr. Dorado here, back again with another video for you guys. So today we are going to be taking a look at section 2.6. So we are nearing the end of our unit on graphing linear equations. Okay, and one of the biggest important things to do in order to graph these equations, especially when you are given points only, is to be able to calculate slope. So that's one of the things that we're going to do today. Okay, so our objectives are to determine the slope of a line algebraically and graphically. Okay, also we're going to determine the difference between positive, negative, undefined, and zero slopes. Okay, let's go ahead and take a look at these problems here. So first things first, we need to define slope. So let's go ahead and do that now. Go ahead and get our pen tool here. All right, so a slope is the rise, in other words, change in x, change in y, over the run, or change in x. Okay, so it's the rise. Let's try that again. It is the rise over the run. Okay, so it's the rise over run, and another way of saying it is, go ahead and write it in other words here. It is the rate of change. Hence why I wrote change in y over change in x. So it's the rate at which each of those values changes. Okay, so let's go ahead and take a look at what a positive slope looks like. So a positive slope is basically as you are looking at your graph and you're traveling from left to right. Let me get my highlighter tool here. So as I'm traveling from left to right, I'm increasing, okay? I'm coming up to a certain point, so it keeps increasing here. So we say that this graph rises to the right, okay? So if we're rising to the right, that means that we have a positive slope. Now, as I travel from left to right on this other graph, what do you notice my pen is doing? It's actually going down. So as I'm going from left to right, I am going down right here. Okay? So it just keeps going because remember we have our arrows there, so it's going to keep going down forever. So we would say that on a negative slope we fall to the right. So again, positive slope we rise to the right, negative slope we fall to the right. Okay, so just like before, like we said above in our definition, the slope is the rise over the run. Okay, and also something to always remember is that you're always looking at these graphs as they come from left to right. Oops. Always from left to right. Okay, that's how you can determine your slope. So let's go ahead and look at a few problems here. All right, so remember what we said. We said it's the rise over the run, the change in the y, so how much up or down I go, and then how far left or right I go. So let's go ahead and go again using our rule of thumb here, and I'm going to go ahead and highlight it for you guys. From left to right. So the first point I see here on the left is this one, and we are traveling to the right point. So let's see how much we actually travel. Remember, rise over run. So we rose 1, 2, 3, 4, 5, 6. Okay, so 6 up, and then to the right 1, 2, 3, 4. So our slope here is 6/4, which actually we could reduce a little bit because they're both divisible by 2, right? We could divide both by 2. So this really becomes 3/2. So my slope here is 3/2, or 3/2. Okay, let's take a look at the next one. So again, starting from left to right. So the first point on the left here is this one, and we are traveling to the right, that one. All right, so let's go ahead and calculate our slope. So first, rise or fall, actually in this case, we are going down. So I'm going to go down 1, 2, 3, 4, 5. So I went down 5, and then I'm moving over to the right. 1, 2, 3, 4, 5, 6, 7. Okay, so right 7 in this case. So if I go ahead and write my slope, I get -5/7, and that does not reduce at all, so I'm going to go ahead and just write that as my slope, -5/7. Okay, so let's go ahead and look at number 3. Same thing, rise over run. So how many am I rising? 1, 2, 3. So I rose 3, and I move to the right 1, 2. Okay, good. So this one had a slope of 3/2, just like our first graph. Okay. Now I want to point out a few things here before I have you guys try some on your own. Notice that the only one that goes as it's coming from left to right, and it's actually going down, it's falling, is number 2. Okay. As you start from the left and go down to the right, you're going down. Hence why we have a negative slope. All the other two, 1 and 3, have a positive slope because as they come from left to right, they are rising to the right. Okay? So what I want you guys to do now is try a few on your own. So go ahead and do 4 through 6 for me. So go ahead and pause the video and we'll come back and double check those. Okay, let's take a look at these guys. So I'm going to do these in red. So let's see what we can do. So first off, rise over run. So 1, 2, 3, 4, 5. So I rose 5, and then I run 1, 2, 3, 4 to the right, which is a positive 4. So I have a slope of 5/4. Next one, again, always from the left point to the right point. So I'm going to start here. So I'm going to actually drop 1, 2. I went down 2 to get to my next point, so it's a -2. And I go to the right 3. So I went down 2, right 3. So -2/3. All right, actually, let me rewrite that one because it looks a little ugly here. So -2/3. Okay, the next one is, again, rise over run. So I rise 1, 2, 3. I'm going to put a 3 there, and then I go to the right 1, 2, 3, 4, 5, 6. So I really have 3/6, but these are both divisible by 3. So if I divide each of those by 3, I get 1/2. So my slope is really 1/2. All right. So hopefully you guys have similar answers. All right. Now, again, like that observation I made earlier, number 5 here is the only one that goes from left to right, and it's actually dropping. It's falling as it goes from left to right. So that's the only one with a negative slope. So hopefully you guys are making those conclusions and those observations as well. All right, so we had good practice now calculating the slope if we're given the actual graph. But now let's talk about how we can calculate the slope algebraically. So in order to always be on the same page about slope and describing it and being able to identify it, we actually chose a variable in math to represent slope. In this case, it is m. Okay, m is always our slope. Okay, and the formula we have to calculate slope when we're given 2 points, so actually, let me write that here, given 2 points, is this right here. So let me go ahead and highlight it for you guys. Okay, so it's y2 minus y1 over x2 minus x1. So again, given these 2 points right here, and hopefully my pen starts to work here, given 2 sets of points, so an x1, y1, and an x2, y2, we just take those values, we literally substitute them into this equation, and we calculate our slope. Now notice at the very top, guys, right here, that it has y2 over y1. Remember what I said earlier in my definition of slope. It was the change in y, or the rise or fall, over the change in x. So if you ever forget where the values go, if it's the x's on top or the x's on the bottom, just remember rise over run is the change in y over the change in x. Okay, so write that little side note for yourself if you would like. Okay, but the main one that we're going to be using is that green highlighted one. Okay, so let's go ahead and take that into problem number 7 and see what we could do with it. So what I like to do off the bat, and if it helps you, I would say definitely try it out, but always label your 2 points as x1, y1 and x2, y2. So this right here is my x1, y1, and this here is my x2, y2. Okay? Now, just to always make sure that I'm substituting everything in the right spot, I'm going to go ahead and actually rewrite my equation that I have right here. So I'm going to do m equals y2 minus y1 over x2 minus x1. Okay, the only reason I wrote it is so now I know where I have to place all of those values that I was given. Actually, let me take a different color now. So my y2 is here a -1, and then minus my y1, which is a 3. Then I have x2, which in this case is a 6, minus my x1, which is a -2. All right, well, -1 minus 3, that's just a -4. And 6 minus a -2, so the opposite of a -2 is like a positive. So 6 plus 2 is 8. Now, both of those are divisible by 4, so I really get -1 over 2. So my slope here is -1/2. All right. So hopefully that started to make sense. Like I said, if you need to break it down into steps, guys, that's how I would go ahead and break it down. Write x1, y1, x2, y2 on each of your points. From there, remember your formula to solve for the slope. Substitute the values into that formula and then calculate your final slope. So let's go ahead and try one more, and then I'm going to have you guys try a few on your own. So let's see. Once again, let's write down what we know. This is x1, y1, x2, y2. Okay. Now, I'm going to show you guys in a second that it actually doesn't matter which one you name x1, y1, and x2, y2. But for now, let's go ahead and continue this way. Okay. So let's go ahead, and we know that our equation is y2 minus y1 over x2 minus x1. So what do we get? We get, let's see, y2 is -8 minus y1, which is -4, over x2, which is 2, minus x1, which is 5. So what do I get here? I get negative 8 minus a negative 4 is a positive, so this is negative 4 over 2 minus 5 is a negative 3. I have two negatives here, so my answer is really a positive, which is just 4/3. So m equals 4/3. Okay. Good. Now, let's pretend for a second that I actually named them differently. So I'm going to go ahead and rewrite my points here. So I had, and let me do it a different color so we don't get confused. So we had 5, comma, negative 4, and 2, comma, negative 8. Okay. So those were my 2 points. Now, I said that it doesn't matter which one you name x1, y1, and x2, y2, as long as you stay consistent with your formula, your original slope formula. Okay, so let's actually name this one x2, y2, and this one x1, y1. Okay, so again, let's write our original formula to solve for the slope. Okay, so let's substitute our values in now. Let's see if we actually do get the same answer. So y2 is in this case now negative 4 minus a negative 8, okay, over x2 is now a 5 and x1 is now a 2. Okay, so let's see what we get. So negative 4 minus a negative 8 is really a positive, so negative 4 plus 8 is actually a 4. 5 minus 2 is a 3. So my slope here is 4/3, and look at that. Both of these are exactly the same. Okay, so that's a property of slopes. It doesn't matter whether you were to have started with the first point or the second point, as long as you're using both of those same exact points, and as long as you keep the formula for slope consistent. Okay, so what I want you guys to do now is get used to calculating your slope. So I want you guys to try out number 9 and 10. So go ahead and pause the video and we'll come back and check those out. Alright guys, let's go ahead and calculate these slopes. So it helps, as I said before, if we rewrite it as y1, x2, y2. And now, like I said earlier, it doesn't matter which one you name x1, y1, x2, y2, except for because maybe just the way I like to do it, I always end up writing x1, y1 on the first point I see. But you can do whichever way you want. Okay, so let's go ahead and find our slope here. So we know our equation for m equals y2 minus y1 over x2 minus x1. So what is my y2? Well, my y2 here is negative 6 minus my y1, which is 0. x2 is negative 9 minus my x1, which is 7. So negative 6 minus 0 is a negative 6. Negative 9 minus 7 is a negative 16. Now, I can tell you right now that from that, we can do a little bit more, because those two are definitely even numbers, meaning they definitely have a 2 in common. So if I divide both of those by 2, I get a negative 3 over negative 8. But even more so now, I can actually say that this is a slope of m equals 3/8 because I have two negatives. A negative divided by a negative is a positive, and so my slope is 3/8. All right, good. So hopefully you guys got a similar answer. I'm curious if some of you guys actually tried putting x2, y2 for your 0.7 comma 0. If you did, you still should have gotten the same answer. And actually, if you would have done it that way, I don't think you would have gotten any negatives in your result originally. So maybe sometimes it's better to do it that way. Okay, so let's go ahead and try out number 10. Let me grab my red pen here. So what do we have? So again, I just, to make sure I'm doing this right, I always rewrite my equation. If you start to think that, oh, I don't have to keep doing that anymore, I know what to do, then you know what to do. That's totally fine. If you feel comfortable doing it, then go for it. Okay? Just always verify that you got your answer correct. All right, so let's go ahead and start with my substituting of values in here. So my my y2 is -5 minus my y1, which is -1. X2 is 4 minus my x1, which is -2. All right, in the top I get -5 plus 1, which is -4. The bottom I get 4 minus the -2, so again another plus, which is just 6. Just like before, we have two things that are definitely even, so I can divide them by 2. Okay, so I get -2 over 3. So my slope equals -2 over 3. All right. So I think you guys had some good practice with that. So in order to wrap everything up for this section, we're actually going to take a look at problems 11 and 12. All right. So let's see. What are they asking us? They're telling us plot the given points, then calculate the slope graphically. And I'm actually going to add and algebraically. Why not? Okay. All right. So let's go ahead and see what we could do here. So not sure what's going on here. Whoa. Sorry about that, guys. I'm not sure exactly what's going on here. So let's see if we can figure this out. All right, let's see. Sorry about that, guys. My computer is going a little haywire here. So should be good now. All right, so I want to solve this graphically and algebraically. So again, I apologize for that. So why don't we go ahead and graph both of those points. So number 11, we have 2, 5. So starting at the origin, I go to the right 2 and up 5. So really my point is this one. I just used this little bottom one as a guide. Okay, so I'm going to erase it. So 2, 5, and then -6. So left 6 and up 2 is our graph. So what I'm going to do now is try to draw a straight line between those two. Okay, that wasn't too bad. All right, let's go ahead and analyze what our slope is here. All right, let me see if I can get this to stay. Okay, maybe that's what happened earlier. Okay, so let's see. We can analyze this and calculate the slope graphically. So let's go ahead and use the graph to calculate the slope. So from the left to the right, remember, point furthest to the left to the point to the right. So what do? I go up 1, 2, 3. So I went up 3, and I go to the right 1, 2, 3, 4, 5, 6, 7, 8. So rise of 3, run of 8. So my slope here is 3/8. Now, if in fact I am correct about this 3/8, then there's no way, or there's no reason why I should not be able to calculate that slope given our slope formula. So let's actually try that out. Let me scroll down real quick. Let's calculate our slope algebraically. So we have y2 minus y1 over x2 minus x1 is my slope. So I'm going to call this let's see, I'm going to call this x1, y1, and this one is x2, y2. Okay, so let's go ahead and try that out. So our y2 here in this case is 2. So let's do 2 minus y1, which is 5, over x2 is negative 6 minus 2. So I get, what do I get here? I get negative 3 at the top and a negative 8 in the bottom. So I have a negative divided by a negative. We know that always equals a positive. And yet again, notice that these two are exactly the same. So now you have two different methods of calculating your slope. Okay, so let's go ahead and try out number 11 together. Okay, I'm sorry, number 12 together. So let's go ahead and give that a shot. So first things first, let's go ahead and graph the point 1, comma 3. So right 1, up 3. Okay, all right, let's try graphing 4, comma 0. So we have right 4 and no change in y, so we don't go up or down. All right, and then let's see, let's go ahead and draw a straight line through there, or at least try to. Could have been better, but I'll let it go for now. So we have our graph. Okay, now from there, remember, we're trying to see if we can calculate the slope graphically, all right? And then what we're going to do is compare it to what we can get when we do it algebraically. So let's go ahead and start at our point furthest to the left. Then I'm going to go to the point on the right. So I have to go down 1, 2, 3. So negative 3. And I go to the right 1, 2, 3. So what do I get for my slope? I get negative 3 over 3. Well, that reduces to just negative 1. So my slope here we're saying is negative 1. But let's actually test that out. Okay. I'm going to grab my pen here and do m equals y2 minus y1 over x2 minus x1. Okay, once again, I'm going to name my first point x1, y1 and my second point x2, y2. So I'm actually going to get 0 minus 3 and 4 minus 1. So let's see, in the top I get negative 3 and the bottom I get 3, and it's already looking familiar. I get negative 1 for my answer. All right, cool. So I think, let's see, do we have a few more? Yes, we do. Okay, so hopefully that made a little bit of sense, guys. If it didn't, like I said, it's always nice to be able to go back and rewatch those videos. So go ahead and rewatch those, guys, if you need to. Okay, so what are we doing now? We're actually going to take a look at horizontal and vertical lines. And just like we said in the last section that those were a little special, well, so are their slopes. So they're a little bit different than the slopes that we've been calculating, because usually we're having graphs that have slants to them. These are either perfectly straight up and down or perfectly straight left and right. Okay, so let's go ahead and figure out our slopes here. Now, we have two ways of doing that, and what I want to do is actually explore both ways so you guys get an idea of why this is true. Okay, so taking my marker or my pen, I want to calculate from left to right. Well, actually, is there a left to right? No, because they're right above each other. So I'm actually going to start right here at this bottom point. Okay, so I'm going to calculate my rise. So what is that? 1, 2, 3, 4. So my rise over run is 4 over. Well, am I moving to the left or right at all to get to that point? No, I just went straight up. I just went up 1, 2, 3, 4. That's it. That's all I did. Now, if I didn't move left and right, that just means I have a run of 0. So what I want you guys to do right now is, if you have your calculator on you, go ahead and divide 4 divided by 0. Okay? Now, if you already tried that out, then you'll notice you'll get an error. This just means that this right here is an undefined slope. Okay, so let's start to make already a few conclusions here, or a few observations. If I have a vertical line, I will never move left or right, meaning I will never have a run. I'll have a run of 0. Okay, and if I'm ever dividing by 0, I do get an error, meaning that for vertical lines, we have slope undefined. So go ahead and make a little note there for yourself. So vertical lines have a slope that is undefined. Now, let's go ahead and do the same thing here on the right. But actually, what I'm going to do on this one, instead of using my graph to find my slope, I'm actually going to go ahead and calculate it. So what are the ordered pairs of these 2 points? So this is -3. Let's see, that's -3 comma 2. And this one here is 3 comma 2. Okay, so once again, I'm going to actually calculate my slope. So y2 minus y1, 2 minus 1. If you wanted to, you can actually solve it just like I did number 13, but I want to show you guys that both methods will work. So my y2, I'm going to actually name, let's see, I'm going to name this one. I'm going to name my first point the x1, y1. So let's go ahead and type that in. So x1, y1, and this will be my x2, y2. If this will ever go, there we go, x2, y2. Okay, so let's go ahead and calculate that out. So my y2 is 2 minus, well, my y1 is also a 2. Okay, now I have x2 is 3 minus a -3. So what do I get this time? I get 0 over 6. So once again, guys, I want you to go ahead and type that into your calculator if you have it. 0 divided by 6. If you divide 0 by any number of times, what do you always still get? Well, you get a slope of 0. Okay, so let's make another set of conclusions here. Horizontal lines have slope equal 0. So vertical lines have slope equal undefined. Horizontal line have slope equals 0. So what I want you guys to do is try either of those 2 methods, guys, that I did above. So either the method I did in number 13, which was just count using the graph, or do number 14 by using the actual formula for the slope. So go ahead and try out number 15 and 16, and we'll see how you guys do. Alright guys, so if you guys did the slope formula, that's totally fine. To save a little bit of time though, I think I'm just going to go ahead and do my graphing, use the graph to go ahead and calculate slope. So I know that my slope is rise over run. So my rise here, I'm going to just start from the bottom. It doesn't matter which one you start from, we're going to get the same answer. So I do 1, 2, 3, 4, 5. I rose 5. I did not move left or right at all. So I get a slope of, whoops, sorry, I almost made the same mistake. Maybe some of you guys would make, but let's double check. This is 5 divided by 0, okay? That is undefined. Okay, so my slope is undefined. You cannot divide by 0. Okay, number 16, same thing. Rise over run. I'm going to start from the point furthest to the left. My rise, well, I don't have to go up or down at all. I just have to go to the right to get to the other point. So I'm not going to have a rise, but I will have a run. 1, 2, 3, 4, 5, 6, 7. 0 over 7, that just equals 0. So my slope here is 0. All right. Finally, number 17 and 18, let's go ahead and calculate that out. So these, we definitely do have a slant going on. So these, we're probably going to go ahead and assume we do have a slope, whether it's positive or negative. We don't know, but we can go ahead and calculate that now. So I'm going to go ahead and do this method the same as the ones above, and then I'm going to do number 18 as the slope equation method. But again, you guys can try whichever method you like. So my rise over run, which is my slope, okay, start from the left point, so go up 1, 2, which is a positive 2. My run is 1, 2, 3. Go to the right 3, so my slope is 2/3. Simple enough, right? So I went up 2 and to the right 3. Simple enough. So again, if you have your graph, maybe that's the easiest way to do it. However, if you are given 2 points, you can always use the actual equation. So let's go ahead and do the same over here now from the right side. So we have this point furthest to the left. Okay, I'm actually going to go ahead and write the coordinates for that. This is 1, 4, and this other one is 0. Whoops, sorry about that. 4, 0. 4, 0. So I'm going to name this x1, y1. This one x2, y2. If I use my slope equation, then I always like to rewrite it to make sure I'm substituting values in the right place. So what do I get? I get y2, which is 0 minus 4 over 4 minus 1. So I get negative 4 over 3. I can't reduce that at all, so my slope is just negative 4 over 3. Now again, if you're not convinced for some reason, remember you can always go ahead and do the other method. Okay, so starting from the left point all the way to the right point, you can go ahead and count down which values you're going. Okay, so I'm going to actually start from the left again. So I'm going to go down 1, 2, 3, 4. Whoa, something is off here. Did I not calculate that right? Oh, that's why. This is supposed to be a 5. I apologize for that, guys. See, that's why it's always a good method to go ahead and check your answers. Okay, so actually that one was supposed to be a 5. So this coordinate right here, let's go ahead and change that. This is supposed to be a 5. Okay, so this should be 0 minus 5, and this should be a 5. So negative 5 over 3. So that's the calculated portion. Now let's double check it with our counting. Okay, that's the reason why you should either try both methods to verify your answer, or just to always go back and check that you are doing everything correct. So originally I went down 1, 2, 3, 4, and now one more. So I go down 5. Okay, 5, and then I go to the right 1, 2, 3. So I went down 5 and right 3. Yet again, it's negative 5 over 3. Good. All right, I think we are pretty solid on that, and I hope you guys are. If you do have any more questions on that, you can either ask me, or you guys can go ahead and double check that video again. So go ahead and rewatch the video, or pause at any moment to try some on your own before you actually look at the answers. That's probably the best way to do this, to always test yourself, see if you understand. All right, so let's go ahead and look at our mixed review. Let's just make sure we remember how to do these. Okay, so we're being asked to graph the following equation using a table of values. Now remember, I always said before that it's always a good idea to start with x equals 0. Okay, so if I start with x equals 0, now I have to identify how much am I going to go down by or how much am I going to go up by. Okay, so what I'm going to do is actually, because this here has a denominator of 2, I'm actually going to make sure that I have whole numbers as outputs, as my y values. I'm going to actually go down by 2 and up by 2. Okay, you'll start to notice that if you do that, if you just follow what the denominator is, if you go up or down by that amount, you will always end up with whole numbers as your outputs. Okay, so let's go ahead and substitute a few of these values in. So -4 times negative. So all I'm doing here is taking this number and substituting it in for my x right here. Okay, so -1/2 times -4. So I'll show you guys the first one. Y equals -1/2 times -4 minus 3. Okay, -1/2 times -4 is a positive 2. 2 minus 3 is just a -1. Okay, now I'm not going to show every single one of these, so you guys can either go ahead and try it on your own and do those problems written out, or you can use your calculator. So now we're going to do -1/2 times -2. That's just a positive 1. And then minus 3 is a -2. All right, next one. 0 times -1/2 is just 0. Minus 3 is a -3. And hopefully you guys can already start to see this pattern. As you're going down, I'm going down by 1. Okay. If you see it, great. If you don't worry about it. It'll become more important later on. So I'm going down by 1. So I'm correct. We should already be able to predict that this is going to be 4, and the next one's going to be -5. So let's actually try it out though. -1/2 times 2, that should be -1. -1 minus 3 is a -4. So we were right on that one. -1/2 times 4 is -2. I'm sorry, a positive. No. It is a -2. I'm sorry about that. It's a -2, and then minus 3 is a -5. So we do have our answer correct. So let's go ahead and actually graph these points. -4, -1, right down here. -2, -2, so -2, -2 is right here. 0, comma, -3, 2, comma, -4, and 4, comma, -5. So let's go ahead and see if we can draw a straight line through there. All right, I drew it in 2 strokes because it's kind of hard to draw on this laptop. Oh yeah, that just made it worse. So just go ahead and try your best, guys. Okay. So we have our graph, and let's see, are we being asked anything else? Nope, that's it. We're just going ahead and substituting in all our input values into our function. From there, we were able to take out our output values. Okay, so let's go ahead and try out number 20. If you guys want, go ahead and pause the video and try this on your own before we go over it. If not, just go ahead and follow along. So as I said before, we always look at the denominator here. Now the denominator here, even though we don't have one, we can say it's 1. So that's a clue that we should start at 0, but go up or down by 1. So I'm going to do -1 here, -2, +1, +2. So again, I'll do the first one written out so you guys can look at what I'm doing, and then I want you guys to either use your calculator or continue writing the algebraic form down to check your answer. Okay, so it's y equals 3. My first input is a -2 for x plus 1. Okay, so 3 times -2 is -6, plus 1 is a -5. Okay, 3 times -1 is -3, plus 1 is a -2. Again, I'm just substituting those x values into the actual equation. So the next one would be 3 times 0, which is just 0, and then plus 1 gives me a +1. 3 times 1 is 3. 3 plus 1 is 4. And finally, 3 times 2 is 6. 6 plus 1 is 7. And hopefully you guys were able to see that because this is a linear graph, a linear function, you should be going up or down by the same rate. Okay, by the same, again, start thinking back. What did I say was a rate earlier? The slope. Okay, so I'm going down by the same rate or the same slope, which is actually a positive 3 here. I'm adding 3 each time, which makes sense because I have a positive 3 for my slope. So now the final thing is just to go ahead and graph this particular line. So let's go ahead and graph the first point, which is -2, -5. Okay, so -2, -5 is right down here. All right, then -1, -2, right there. 0, 1, 1, 4, and 2, 7. Great. Let's try drawing a straight line with a straight edge. It's pretty straight, but not through my points, but you guys get the idea. All right. So I think that's actually it for today, guys. So go ahead and rewatch the video if you want to make sure everything makes sense. If you do have time to see me around school, make sure you go ahead and ask me personally. All right, guys. Well, have a good one, and I will see you guys next time.